Hi, welcome to UncleRebbInTech channel. UncleRebbInTech is a video channel that hopes to share knowledge to all technocrats and have fun. Today, I would like to start a new series about software architecture. This is not a programming 101 lesson and are more suitable for students or developers that already know basic of a programming language. Throughout this course, I'll be using TypeScript as an example. It is okay if you have not tried TypeScript before. Following this course, I will guide you on how to set up necessary environment, install packages, and you can pick up TypeScript on the way. Alternatively, you can also follow me by using another language you are familiar of. If you like my training video, please like and subscribe. So, what is software architecture and why is it important to know about it? Before we dive deep into software architecture, we need to learn what is it. Well, it's easy to develop a software. High school kids do it all the time. Students from college do it also. They just need to put in some patience, and with sufficient willpower, they can produce a working software that works. It isn't that difficult. But is that all it takes? If it's really so simple, we don't even need to talk about software architecture. So, why? Well, it is easy to develop software that works once, but ridiculously hard to get it right. So, what is getting it right? How does it look like? How does it feel like? To understand what is getting it right, I think it's a good time to share a story of mine with a little drama elements, of course, to demonstrate what is getting it wrong. It's story time. Once upon a time, when I'm just a young, inexperienced developer, I decided to join a startup at a very early stage as the sole developer. I'm a hardworking developer. I work on weekends, OT, almost every day to get a new feature out. I say yes to everything, from asking to code faster to resolving technical debt later when we have more developers. The first 3 months was, at least to me at that time, was a productive one. I am delivering features like driving on a highway without cars, full speed ahead. I didn't realize there was hidden danger of technical debt. As the startup grows, like all other startups, we need to hire more developers to help with delivering features at an even faster pace, to keep up with our competitors. But even with more developers, we realized our pace of delivery, new features was slowing down. It slowed down to the point like driving on a highway full of cars now. Nothing is moving. There was lots of errors and bugs everywhere, and technical debt were piling like landfills. Our developer, including me, changed my profession into firefighters, and what I do is just to put out fire every day. And soon, without us noticing, we sink into a cycle of no return. We realize that we need more output. So to increase the pace of delivery, we need to hire more developers. Having more developers does help in delivering new features on time, at least on the start, but it also generate more errors, bugs, and technical debt. Having more errors, bugs, and technical debt slow us down, and we need to maintain the pace of delivering new feature. So, we need higher output again. And the cycle goes on until one fine day, our stakeholders said we can't hire more developers. So, from then on, our developers need to work long working hours, and with constant firefighting that caused developers to burn out. Productivity is reduced, and as you know it, when productivity is reduced, more errors, bugs, and technical debt were generated. No new features is added from that point onwards. All developer hands are so full on resolving errors, bugs, and technical debt, nothing can be done. Of course, stakeholders were furious when we stopped delivering. They start to ask why we are so slow, why there are so many bugs. And sometimes they too wear the hat of a developer, asking questions like, this change is so simple, why do you need to take so long to build it? And all this cycle and frustration encountered in this story are what we call the signature of mess. There are no consideration of structure, maintainability, readability, and with mountains of technical debt. Users sheer number of developers as a sole driver to deliver new features. And also, stakeholders and developer believe that the definition of technical debt is not just the scope of work, but also believe in the fairy tale that ignores structure and principles defined can save time. Scope of work can be added later on, but ignoring structure and principle will cause a big mess later on. I have seen many and believe that this story of mine happened over and over again, no matter in a startup environment or even in enterprise projects. The moral of the story? Take software architecture quality seriously. So, why is software architecture? Well, simple. To prevent building a big mess that's beyond recovery. A mess are expensive, manpower intensive, and not fun to work at all. In this course, one of the key focus is structure versus behavior. In a software project, there are two types of value. Behavior, as we know it, represents how software behave that can either save or earn money for the organization. Structure, on the other hand, are technical details such as adapters, database layers, third-party libraries, or even frameworks like MVC, or structured decisions like microservices, service-oriented architecture. In my over 10 years of experience in working at different industries, from startup to government, behaviors are always the focus, where structure are given very low priorities. One of the goals we will achieve is to balance the structure versus the behavior. We will talk how structure should be flexible and as structure agnostic as possible, and how behavior can fit into different kind of structure. All software start with code. And the first topic is down to the very bottom, the programming paradigm. We will talk about two main paradigms, object-oriented programming, and also a little about functional programming. Thanks for viewing, and if you like my video, please like and subscribe.